Hello everybody! In this video I will help you with your June exam preparation and I will discuss question 8 of the 2021 paper. Remember, 27% of your paper is on trigonometry. This is the question. I suggest you pause the video, quickly attempt the question and then come back to the answer. In the diagram below, T is a hook on the ceiling of an art gallery. Points Q, S and R are on the same horizontal plane from where three people are observing the hook T. The angle of elevation from Q to T is X. QSR is 90 degrees plus X. QRS is X. QR equals 5 units and TS equals SQ. Prove that QS is equal to 5 tan X. QS, it's this one over there. Alright, so we will be working in triangle SQR and we have this angle S, and we have this side QR. We have this angle R over there and we want QS. So it's very clear that we're going to use the sine rule. So we write it as sine S over QR and sine R over QS. And we substitute the values. Then what's important here is this sine 90 plus X. That is a reduction formula and it can be reduced to cos X. And then in the next step, we want to make QS the subject of the formula. So what we do is we cross multiply and we get that QS is 5 sin X over cos X and sin X over cos X is tan X. So where's the marks for using the sine rule, the substitution and the answer? 8.2. Prove that the length of QT is 10 sin X. So we are looking for the length of QT. So it's very clear that we're going to work in triangle TSQ. What we know is that this angle is also X, since this is an isosceles triangle. And then this angle at S there, that is going to be 180 minus 2x, because the angles of a triangle add up to 180. And then since we have two sides and the included angle, we will be using the cosine rule. So to write the cosine rule in terms of this triangle is going to be QT squared is QS squared plus TS minus 2 QSTS, the cos of angle TSQ. And then we substitute in the values. So we know that from the previous sum, the length of QS was 5 tan X. And then the same will be for TS because it's an isosceles triangle. So in TS's place, you also substitute 5 tan X minus 2, 5 tan X, cos 180 minus 2x for angle S there. And then in the next step, what we're going to do here, we're going to say 5 squared is 25 and tan X squared is tan squared X. So this one becomes 25 tan squared X, that one 25 tan squared X. And then here we're going to say 2 times 5 is 10 times 5 is 50 and tan X times tan X is tan squared X. And then for now, this cos 180 minus 2x will just be carried down. And then now we can say that this is a reduction formula. The cos of 180 minus 2x can be reduced to just cos 2x, but cos in this quadrant is negative, so therefore there's a negative cos 2x, and then this negative is that negative from the sum. And then what I did here, I said 25 tan squared x plus 25 tan squared x is 50 tan squared x. That minus is that minus, and that minus, as I said, came from cos 180 minus 2x. That was reduced to cos 2x, and that cos is negative in the 180 minus quadrant. In the next step, what I did here was I just multiplied in the minus, and then I said I can take out 50 tan squared x as a common factor, and then when I take it out there, I will be left with 1 plus, and when I took out 50 tan squared x, I'm just left with cos 2x. And then suddenly this looks very familiar. It's a double angle. And let me do it here. Are you with me? Cos 2x is the same as 2 cos squared x minus 1, the double angle. So in the place of the cos 2x, I substituted the double angle's value there. And then what I'm going to do is, in this one, I said 1 minus 1 is nothing. And then there's the 2 cos squared x. And now 50 times 2 is 100. Tan squared x times cos squared x. And then tan squared x is the quotient identity, which is sin squared over cos squared. And then the cos squareds will cancel, and I'm left with 100 sin squared x. But on the left-hand side, there was qt squared. So to get rid of that, I take the square root, and I get qt is 10 sin x. Where's the marks? The cos rule for reducing that one to the cos 2x, for recognizing the double angle, for making tan squared into sin squared over cos squared, and the final answer. 8.3. Calculate the area of triangle TQR if TQR is 70 and X is 25. So TQR is this triangle over there. Can you see? It's like we're having this upright triangle. It's that one. And then the angle for TQR is 70 degrees. So it's this angle there. That is 70 degrees. And then X is 25. Where does the X come in? Remember, this is not, or rather, the previous sum we worked out that TQ was 10 sin X. And now, if we want the area rule is half TQ times QR, the sin of TQR. And then half TQ from the previous sum was 10 sin X, but X was given that it's 25. QR was given that it's 5 units, and then sin TQR, and that one was also given that it's 70 degrees. Substitute everything, work it out with your calculator to 2 decimal places, and you get the area as 9,93 units. Where's the marks? Area rule, answer.
Here you will find on the right hand side are the playlists of grade 11 and 12 trigonometry. The video in the left hand corner will take you to the next question of this paper, which was Euclidean geometry.